In this section, we're going to cover the empirical gas laws, and there's going to be 4 different ones: Boyle's law, Charles's law, combined gas law, and what's called Avogadro's law. Boyle's law is a relationship between the pressure and the volume of a gas, and it varies inversely, which means that as one goes up, the other goes down. And that is shown, let me change my, oops, that is shown over here. That my normal pressure, and I have 100 milliliters, if I double the pressure, then this here only becomes 50 milliliters. If I triple the pressure from the original pressure, this becomes the 33 is 1/3 of the pressure. So there's a direct, as I increase my pressure, my volume becomes smaller here. So that's what inversely means. As you increase the pressure, the volume decreases, or if I increase the volume, the pressure decreases. The equation given to you on the formula sheet is PV is a constant. We're actually going to use PI/VI is equal to PF/VF. This is very similar to what you saw with molarity concentrations. In these problems, it will usually state the fact that it's at a constant temperature, or it gives you the same temperature twice. And gases do not follow Boyle's law at high pressures. This is an example of the, oops, okay, I need to turn that off. There we go. This is going to be an example of Boyle's law. And get this over here.
In a demonstration of Boyle's law, we'll place a balloon in a vacuum bell jar. We'll apply a vacuum which basically pumps out the air in the bell jar. The pressure outside the balloon will be greater than the pressure inside. The balloon expands to try and equalize the pressure. Volume and pressure are inversely related to each other. When we release the vacuum, the pressure increases and the volume decreases. As another demonstration of Boyle's law, we will put a marshmallow peep into our vacuum jar. The marshmallow contains air trapped in a mixture of gelatin and sugar. As we apply the vacuum, the pressure outside is lower than the pressure inside. The air in the peep will expand to try and equalize the pressure. When we release the vacuum, the pressure increases and the volume decreases. As another illustration of Boyle's law, we will put some shaving cream into our vacuum jar. The shaving cream contains air trapped in a soap mixture. As we apply a vacuum, the pressure outside is lower than the pressure inside. The shaving cream will expand to try and equalize the pressure. As you decrease the pressure, the volume increases.
Okay, now let's do some problems like that. So the first one is to compress nitrogen at 1 atmosphere from 750 milliliters to 500 milliliters. What must be the new pressure if the temperature is kept constant? So here is the temperature is kept constant part. So we're going to do these the same way. Okay, I have a pressure of 1 atmosphere. I have a volume of 750 mLs. I have a volume of 500 mLs, and then it wants to know what's the new pressure. So I have a new pressure as the question mark. So just like with molarity problems, the hardest part of this is probably identifying which ones go with which. So to compress 1 atmosphere from 750, so these two go together, so I'm going to label these as I, and the new pressure and the new volume is my final. The equation, of course, is PI/VI is equal to PF/VF. So my initial pressure is 1 atm. My final, or my initial volume is 750 mLs. My final pressure is what I want to find, so I don't know it. And my final volume is 500 mLs. So when I multiply these two together, I get 750, and it's atm times ml when I multiply those. And of course this becomes 500 ml PF, just because we typically put the variable last. So I'm going to divide both sides by 500. So 750 ATM dot ml divided by 500 ml is equal to PF. And the reason I did this is I want you to see that the mL's cancel. And when I divide 750 by 500, I get my final pressure as being 1.5. And the only unit that is left is ATM. You don't have to show the units in the problem. I just wanted to show where it came from. But basically, the volume has to be in the same units in order to cancel, so the pressure is going to end up in the same units also. This one, it says if a 250 milliliter, so therefore I have a volume of 250 mLs of oxygen, you don't have to write down oxygen, but sometimes that's going to come in handy, is millimeters of mercury, which is a pressure of 960 mmHg, is allowed to expand at a constant temperature, again there's your temperature, until its pressure is 760 mlHg. What will the volume become? Okay, so this one, because these are in the same sentence, okay, these two go together, and this is my I. Oops, draw that one down. And these two are, it says until the pressure is, and so therefore those two. So the same formula, when I have two pressures and two volumes, the formula is going to be PI VI is equal to PF VF. So I have 960 times 250 divided by 760, and my VF is what I don't know. I multiplied these two things together and I get 24 with 4 zeros after it is equal to 760 VF. Now I'm going to divide both sides by the 760, so 24 with 4 zeros divided by 760 is equal to VF. So VF ends up being 316, and the unit again is going to be the same. So my volume unit here was milliliters, so my unit is milliliters. Now I meant to stop and point out the fact that I want to double check what happened to my volume in this problem up here. In my first problem, my volume went down. So if my volume goes down, what should happen to my pressure? The pressure has to go up, and so it did. It went from 1 atmosphere to 1.5. So if you're working out problems on the homework, on the test, and you want to check these out, then I suggest you take a second before you do the calculation and see, do I expect a larger number or a smaller number? If I look at this one, I went from 960 to 760, so my pressure decreased. And what should happen if my pressure decreases? Then the volume should increase, and it did. I went from 250 milliliters to 316. Because it's very easy to, if I get these paired wrong, if I had switched out the 760 and the 960, I would have gotten a smaller volume. And so a smaller volume is a hint that in fact, it went the wrong direction. Okay, and so in the next video, we will look at Charles's law.